Hello everyone, welcome to the Kuma community call. I think you see the document. Please add your name to the attendee list, and also feel free to submit any agenda topics you'd like to discuss today. Yeah, we will start with a shortly mentioning of the upcoming Kuma release. It's going to be 1.8 next week. We want to release this. Full list of changes will be available, I guess, next week. So yeah, not much to say about that. Next thing is a Q&A, Kuma and NSM integration. Daniil or Vyacheslav, who wants to take a lead?
Vyacheslav is going to present something.
Oh, nice. Do you want to share screen?
No, it's just we are currently still working on the integration. We have achieved a working use case with universal Kuma and NSM, but it is just too overcomplicated, and we are trying to simplify it by using default Kuma instead of Kuma universal. So at the moment, we want to implement the scenario that is provided by the link. It should be a diagram, so it will be a little bit clear for everyone else what it is. And we'd like to get bootstrapped with Kuma authorization. And could we ask someone who can help us offline with our questions related to authentication and authorization?
Yeah, sure. I mean, you can ask to the community. Oh, development. We have development channel in the Slack, or you can ask me directly, and I can try to figure something out. But usually it's development channel.
Okay, so, thank you. Mm-hmm.
Yeah, about the diagram. Sorry, I just opened it. Do you want to give some details?
Yeah, it is the tutorial that is on inside the docs on kuma.io. So we are using, we want to use Kuma control plane configuration and two deployments that have NSM interfaces, which should allow us to communicate from cluster 2 to cluster 1. So currently, I'm trying to use the authentication to access. So the Kuma sidecar on the second cluster should can access the Kuma control plane.
Mm-hmm.
Yes, I have some kind of problems. Maybe it is related to tokens, maybe to something else. So maybe I will ask questions once I will figure them more clearly.
Okay, so use case you're trying to support is to connect instance sidecar from cluster 2 to the control plane, Kuma control plane from cluster 1. Is it correct?
Yeah.
Okay, and you don't imply that there is like flat network. It could be, I mean, oh no, I think, are they in the same network? I mean, this workload 1 and workload 2.
Yeah,
the requirement.
So there is 3 pods. One should be Kuma control plane. The second one will be Redis with Kuma sidecar, and the third one is demo app with Kuma sidecar also. All 3 of them have network NSM clients. So all 3 of them should have the same NSM interface and should be in the same network.
I see. Okay. Does anyone have questions for this slide? Yeah, thank you, Vyacheslav. It was really interesting to hear what's going on with NSM and Kuma integration. I hope to see what in the future. Okay, so we have Greg for Kuma and Vault plugin. Greg, do you want to share screen?
Yeah, sure thing. Let me see. So as a little bit of preface, we kind of are gonna, so me and Nick, so I have Nick Jackson as well from HashiCorp on the call. And Nick and I have been working on this concept for one of the sessions for the Kong Summit. And so what we were in some discussions and we were talking about Kuma and deploying it out, and I've been working with it, and I was like, I think that managing the secrets with a Vault plugin would be a really cool topic, and also just a thing for groups that already have Vault in place and are looking to do that. So I have been kind of talking with Jacob as well, and we've pushed in some different features to make sure that that this will work well. But we kind of are we're in the process of working on it and doing it. So let me share out. Let's see if I can do this right, because I am working on 2 Macs at the same time. So I'm remoting in from one to another. Let's see. It will even let me. Here we go. All right. All right. So the crux of what we are doing here is we wanted to allow the ability for Kuma data plane and user tokens to be managed with HashiCorp Vault. And so what we did was we originally actually went down the road of leveraging the database secret store. That as we kind of got into that, it didn't quite mesh exactly with what we were looking for with the way the secrets went and forth. So we actually had found another project that was doing something with another API and kind of bootstrapped off of it in order to derive kind of our own secrets engine mechanism for that. So I'll kind of and actually, if any of you guys want to go to this and take a look and make comments or contribute or whatever, it's under my GitHub, Gregory Hunt /vault-plugin-Kuma. So you guys can go there and dig in if you want. So what we on top of this, what we do is we building this on top of this specific plugins testing and stuff on top of Shipyard, which is a demoing tool that Nick and Eric Bell, also from HashiCorp, built in order during their time of doing a lot of demos and kind of building out things like this. So it's a way to manage Docker spin up environments and stuff like that. So that's kind of, we built that on top. But so let's go into, so I'm rambling. So we dug into the core of the plugin is we are leveraging this Kuma, the secret engine in the back, and we're storing the Kuma token, revocation, renewals. And what we're doing is we are balancing all of these different pieces that you would use for requesting a token. And we're having HashiCorp Vault handle that for us. So you can use any auth method you want in order to authenticate against Vault, and then Vault will handle all of the interactions to and from the API. So you would create an admin token, take that admin token, set it into the config of Vault, and then it could then broker all the tokens for you based off of the roles that you've set up in Vault. It can also manage the lease of the token. So you get a default. So when you set up a role, you get a standard TTL of how long that token it lives. It also will give you a max TTL. And so when we provision the Kuma token, we provision that token with the max TTL life. And the user will have to then refresh that token when their TTL expires, or Vault will actually add that to the revocation list and no longer allow you to use that token. And obviously, once you get to the end of the lifetime, you'll have to request the max TTL. You'll need to request the token. So that is a crux of what we're doing here. And here's the different pieces. I don't know if you guys have some questions of what kind of what we're doing. And Nick, if you want to add some better verbiage.
I can show it in action if you like.
Yeah, let's do that.
Let me just quickly show you. Okay. Bear with me 1 second. Let me just quickly reset my demo. All right. So the way that Vault works is that you authenticate against Vault. You have policy assigned to you. And with that policy, you can request secrets. So a secret in Vault, in this instance, is a Kuma data plane or a Kuma user token. So in order to control who has the ability to request those secrets or generate those secrets, you have policy. So for example, here's a simple policy. So I'm saying that I'm going to create this policy, create this role, which will be title policy. And the role is called Kuma role. That is going to allow me to generate tokens, data plane tokens in Kuma with the name of backend one for the mesh default with these given tags. Now, so this would obviously be as part of the automated process of when you deploy your data plane. So you don't need to worry about putting the data plane token onto your virtual machine or whatever it is. You basically can then just use cloud metadata like AWS, swap that for a Vault token. Vault gives you the data plane token. And importantly, the data plane token has a time to live. So in the instance that you want to run like short-lived tokens, more specifically, I suppose, for user tokens is useful, but you can say that after 30 seconds, this token is no longer valid, up to a maximum of renewal period of 2 minutes. So I'm just using really short numbers here for the purpose of the demo. So let me just restart my Vault instance, and I'll kind of very, very quickly show you what's going on. This will just take 30 seconds or so. There we go. Not started yet. Nope, that's just restarting. Okay. There we go. Right. So Vault, I've got Vault running here. So what I'm going to do is I am going to enable the Kuma. Damn you. I'm going to enable the Kuma secrets engine in Vault. Now you could be using any Vault instance for this. It just uses a plugin. So I enable that engine. Then what I can do is I create the configuration. Now let's have a quick look at the configuration here. But the configuration basically is that I'm going to write the configuration. I am specifying the roles that can be used by this configuration, the URL of Kuma's data plane, and an administration token that we can use. So let me just, why did it do that? Let me just set this up. So I've done that. So now Vault is configured with a Kuma admin token. So now what I want to do is I want to generate a role. So I'm actually just going to go and generate this role here. So let me just do that. So that's my role created. So now I've got a role. Now I've got the auth method. I can now generate a token. So to generate a token, you've got to be authenticated in Vault, and then you ask Vault to give you a Kuma token. So I'm just going to use the Vault read command, and this can be also API. You can use Vault Agent. I'm saying Kuma creds the name of my role, which is my Kuma role, and the token name, which is backend 1. And there's my token. So what Vault has done is it's hit the Kuma API. It's used the admin token that's stored securely in the configuration, and it has generated me a Kuma JWT for data plane. JWT util decode JWT, and then decode JWT. And now you can see this is the token that it's being generated. So it's been name scoped to the name of the data plane instance backend 1. It's got the tags, and importantly, it has an expiry. Now, the cool thing is that this data plane token is short-lived. So Vault, if you don't keep renewing the token, which is an automated process, Vault's going to delete it for you, and it'll revoke the token for you. And the TTL on this was 30 seconds. So you can see that Vault has actually revoked this. So just in the logs here, it's logs, so there's nothing exciting to see, but you can see that the token hasn't expired, but I've asked Vault to revoke it for me. It's revoked it. So again, it has hit the Kuma API.
Yeah.
And it's added the JTI to the data plane revocation secret. So now that token has been deleted. So you can either let tokens expire by not having this renewal process, or you can have a break glass procedure where I'm like, that token has to be deleted, or all of these tokens need to be deleted because there's been a breach or something like that, or it's leaked into GitHub.
When he called that original read, it gave you a lease. It gives you a lease ID. That lease ID is tied to that token. So with that lease, yeah, there you go. You could manually revoke it with that lease, but also as an admin, you could revoke all the leases for a specific role. So if for some reason there's a bad actor, or you think there's a bad actor, you can completely wipe all the leases and they'll have to re-authenticate. And that would then add all those to the revocation lists at that point in time. So
yeah.
with this, one of the things that we are continuing to build out on, and we were kind of working before this call, is the next step is that because of the way that the revocation lists are handled as secrets in Kuma, we probably should manage the cleanup of those. So the way we're storing the secret for each user that requested underneath that lease, we're also storing the expiration date with that JTI, so that we will be able to run a process, a kind of a garbage collection every so often that will look for expired JTIs and then remove those from the revocation list, since they would no longer be able to authenticate with them anyway once they've expired for a certain period of time.
Yeah, and just as a kind of another example there, what I've just done is I've just generated a user token.
Yeah.
So you can see the user token here. I'm an admin token, but again, I can specify what groups in exactly the same way as I did with the role.
Yeah.
For Nick, and then I can use that to interact with the Kuma API. So I'm just gonna use my token that I've just minted there to actually just delete a secret in Kuma, so you can see that token is working. And like from the user token perspective, the benefit is that as a user, you authenticate using something that you have, LDAP credentials, GitHub credentials, like whatever it is, personal to you against Vault. Vault allows you access to secrets. Vault then manages that secret for you. So if I accidentally commit my user token to GitHub, if I don't keep renewing it, Vault's going to delete it for me after a certain period of time, or you just use super short TTLs because you know you can easily mint new tokens, and it's just hopefully a useful thing for you all.
And also we added some validation in there as we were digging through it that data plane tokens use tags and user tokens use groups. So when you create a role, you can't specify both. You can specify a role can either have tags and be for a service, or it can have groups and be for a user. If you try to do both, it'll throw out an error there. So
I have a question. So is this Vault plugin? Sorry, I'm a little bit late. I had another meeting, but is this Vault plugin also support issuing the user tokens?
yes,
Yes.
yep, that's what he just did. He just issued the user token with that.
Okay, okay. Sorry, I missed this part. Nice.
And you would tie that policy. So you would create policies that you could add users to, or groups of users through your authentication method. And then those policies would allow you to read the specific roles that you've created. So you could create a plethora of roles that are mapped to a specific set of groups. And then based on their authentication method, they would be able to read those tokens. And when they read that, it issues it. It would then go and request it through the Kuma API and issue it. So yeah. And all it's very configurable with TTLs and max lifetime. All of that you can configure right in your when you create the role, how long you want those to be, and that gets translated over to when it request the token from Kuma.
And the Vault's internal role and security policy will stop you from doing things like generating tokens that you don't have access to. So if I try and generate a user token for Greg, it's like, you can't, because you only have the capability to generate user tokens for called Nick, and that goes for all of the other elements in there as well. So it's it's an additional layer of security to just kind of lock things down in a super granular way. But yeah, this is a user token that I've just generated.
And we have like a few things on our list to add on to that, which are the garbage collection. And then the next thing that we want to add in there is the ability for the engine to rotate its own admin secret. So you would create a short-lived admin secret to actually create the plugin, and then we could trigger a request in there to have Vault rotate its own secret. So it is the only one who knows that root admin secret. So that even there, that takes that layer that, prevents that from being, leaked as well. So you could use that in like a CI/CD process, and then you could tell it to rotate its own secret. And then that initial secret is no longer valid because we added to the revocation list and handle it just like that with a new admin secret. So
so when you're bootstrapping a cluster, you can basically generate that bootstrap certificate and store it in Vault. Vault will rotate it, and then you just delete it. And if you want to get a user token to interact with Kuma, you ask Vault to generate you one, and nobody has the
key to the kingdom.
except Vault, and then so it's
well, about this one, you still have a signing key in the control plane, right, to validate the tokens, right?
Yes.
And from the signing key, you can easily generate any token you want, right? So technically,
correct. So
some of the things
you have to have access to the server, right? To the control plane.
Right. Obviously.
So you have to be local host to the control plane. So
we're not.
Sorry, go ahead.
Well, we can't solve all of those things. There has to be, you have to define your own perimeter, but what it means is you don't have to hand around admin tokens to absolutely everybody. You can use group scoped tokens, and then somebody has to have trust, but that's generally just the cluster operator as opposed to the cluster user.
True. Although we could go extra mile here, right?
Yeah,
If
we talked about this, Jacob. Right?
I'm very interested.
Yeah,
to
the evolution of this is, and we'll do this, maybe tackle this after the Kong Summit. The evolution is completely abstracting the authentication and token minting out of Kuma and only getting Kuma the public key for verification process, and then have something like Vault PKI or something like that completely mint handle everything. So yeah.
Or alternately, you could have Vault manage just the signing keys, and the signing key would be stored within Vault, but we'd have to write with specification if it'd be of interest to find some plugins for Kuma, but it's hopefully useful.
Yeah.
Yeah, it is. It looks very nice. One more question here. I can see in the URL there is HTTP 5681. Do you also support HTTPS calls to the H2 server with a CA verification?
We will.
Okay.
So
Okay.
not in this demo, but we will, because what we need to be able to do in the config as well is to be able to store the CA.
Oh yeah.
When I originally set this up, I was just bootstrapping Kuma with the default setup. I'm actually bootstrapping Kuma in my dev setup here with a certificate, so I could add that into.
Oh yeah,
here.
we could inject that in there from the certificate.
Yeah,
you just added in. Yeah, that's true.
So yeah, 100%. We will support HTTP and HTTPS, which would be our encouraged method of interaction.
Yeah.
We could even make that a default, to be honest with you. I don't know.
Yeah.
Okay, awesome. Is the repo open?
Yes. Yeah. You can go take a look. It's at here, I'll link it in. Yeah, feel free to, do issues, make comments, whatever kind of, as much as you want. One thing we did do, actually, not on the secret side, but on the token side, is we actually incorporated the Kuma CTL library, because the Vault plugin is also just a Go execution of that. So we actually imported in that in order to manage some of that. And then me and Nick were just talking this morning that the secret side, he started digging into the resources and wasn't sure exactly how the Kuma CTL module or package was interacting with the secrets. But here we go. And you should get, we haven't added this to the README, but you should, if you want to use the shipyard, the testing and stuff with that, it uses shipyard, which is shipyard.run. That's take a look at that too. That'll
just a little single binary that just automates a bunch of stuff in Docker. It's kind of like Docker Compose, but with dependency.
Yeah,
it doesn't do anything else.
I'll post that as well, just so that.
So when you're looking at the repo, we do have a full set of functional tests. Well, apart from the revocation, which we just finished off this morning. There's not many unit tests yet, but because we've been kind of like basically poking the bear to try and work out how it needs to grow. But before we make this kind of released and we cut a release of it, it'll have full test coverage. So don't fear that. That's incredibly important for something like a Vault plugin, that it's fully tested.
That's even funnier, Nick, because Kuma is bear in Japanese.
Yeah, it's a very short word, right? So you have like different meanings in different languages.
Yeah, okay, I think we out of time. So maybe we should wrap this up. So thank you, everyone. Have a great day and see you next time. Bye.
Thank you guys. Thank you for your
Till
time.
later.
guys.
Thanks.